footprint and educate pupils, staff and neighbours with a program of continuous improvement. Before we start, a little housekeeping. Please note, during this webinar, we will be using audio broadcast. The small box in the right-hand corner will need to remain open throughout. To chat the host or to submit a question, click on the speech bubble or the question mark in the top right-hand corner and open the Q&A box. If you experience any technical difficulties, please email marketing@imserve.com or speak to us directly through the chat bar. My name is James Palmer and my background is in key account management in the power sector. My expertise is balancing the challenges of customers with the experience and skills of the supplier. Despite being a graduate engineer, I have often found that this is less about the nuts and bolts and more about understanding what key challenges of the customer are. I believe that if we make your life easier, it will be easier for you to reduce costs, improve efficiency, regardless of how that efficiency is defined. A colleague at the side of me here is Jimmy Sohal. He has over 10 years experience in the utility sector and has first-hand experience of the benefits of BEMS, or Building Energy Management Systems. I will explain the concepts behind our theories and we'll focus on the technologies. Let's have an overview of our agenda. First, we will give a brief background of IMServe and then a summary of the challenges we have seen faced by many educational establishments today. Then to the heart of our presentation. How do we measure usage? How do we understand the data? How do we get everyone to buy into energy savings? And then what do we need to achieve this? Our intention is to help you create a path to sustainable energy saving by focusing on these factors. The key is sustainability. We want an environment that not only measures data, but that actually uses that data to drive improvement, and an achieved energy savings looks to continually improve them. IMServe is part of the Invensys family. Invensys is a global technology company that works in partnership with a broad range of industrial customers and appliance manufacturers. They design and supply advanced technologies that optimize operational performance and profitability. In market-leading software systems and equipment to enable customers to monitor, control and automate their products and processes, thereby maximizing safety, efficiency, reliability and ease of use. It's two major divisions centering on control products and operations management. IMServe are a part of the operations management group, but has its own unique history to understand. Understand our position within this, we'll also summarise that for you. It was created by the big six electricity generating companies to collect and aggregate data from half-hourly meters of the UK's major energy users. When the energy market was opened up to competition, IMServe became an independent company, which was acquired by Invensys. We are still one of the largest independent energy collectors, monitoring over 30% of the UK's consumption. However, since we only operate in the commercial sector, if you move domestic usage, this rises to approximately 50%. We use this unparalleled knowledge and experience to understand how energy is used and a platform for driving energy efficiency. There are challenges facing us all when it comes to energy efficiency. At IMServe, we have spent a considerable amount of time speaking directly with our customers to understand their specific needs. They have highlighted the following as the main challenges they face, but there are probably others that you could add. Depending on which part of the UK you live in, the local authorities can face their own unique challenges. More and more schools are achieving academy status. You argue that government control over schools has already been systematically reduced. But the gain of academy status does give schools more freedom on how they spend their money. Budgets are being reduced in almost all departments. Every day we hear in the media stories of more government cuts, which inevitably leads to reductions in local authority funding. Inflation is quite low, but not zero. These cuts have to be achieved against a background of increasing costs. Authorities may also have responsibilities for the provision of adult education, which involves the use of schools or colleges. It's possible to understand the true cost of these without detailed energy information. We recently visited a school that ran evening classes in its IT facility. Unfortunately, it had no way to monitor or control individual departments. It meant that the entire school had to be heated to keep a small portion of it warm. We did them to install sub-metering heating controls, which split the school into several key areas, which was massively reduced, and the return on investment was achieved within 12 months. Authorities still have some responsibilities for CRC. To be honest, I'm not sure about what responsibility the schools and colleges have these days. But improving energy efficiency is an easy way to help reduce CO2 emissions. It has to help with any CRC costs. We do have people who specialise in these fields, fortunately. I visited lots of universities and sixth form colleges over the last few months. The same issues are raised again and again. Expensive technologies, ageing premises, risk aversion, and a greater diversity of students are creating new challenges which lead to increasing demands on budgets. Most energy companies increased prices by over 10% in 2012, and this has followed greater than inflation increases in the 4 preceding years. I donate some of my time to our local athletic club doing their annual accounts. We have seen energy prices increase by close to 50% in the last 5 years, despite switching suppliers to ice. To improve our efficiency, we have had no choice but to address questions on energy wastage. A simple and cost-effective measure was installing a last-man-out relay on our alarm system. It automatically turns off all the lights when the alarm is activated. See later that this can be incorporated as part of a control strategy and done by the BEMS system. Many schools and colleges do not have the ability to break down their usage and attribute it to departments. This can be even more difficult when departments are spread across a campus or multiple sites. I recently worked with a school that had a much higher than expected gas bill as when benchmarked against similar schools. When investigated, we found that the kitchens were on the end of the heating lines. The staff complained that the kitchens were always cold, and to overcome this, they lit all the ovens and the rings when they first arrived. This efficient solution increased the school's gas usage by 34%. Our survey of the site, coupled with discussions with staff, quickly identified this as a major contributor. Changing ductwork would have been very expensive and may have created issues in other areas. The solution was to install a new boiler which was more efficient and generate the required heat. heat at peak demands. This might seem an expensive solution, Fortunately, in their area, grants were available. This, coupled with additional controls, led to considerable saving in their gas bills. We discussed earlier how the requirements of the local authority can lead to out-of-hours usage. But we also need to consider the interaction of schools and colleges with their local communities. My local school runs badminton classes on a Tuesday evening. As a casual user, I pay £4 for a 2.5-hour session. While I obviously don't want to pay more than this, an accurate breakdown of the costs associated with the heating, lighting and showers will allow the school to make better informed decisions on charges. CO2 reduction is being embedded into the curriculum of many schools and colleges. In addition to this, many educational establishments are driving improvements in their local communities. Additional funding is often available for these initiatives. Sixth form college that we had previously worked with were offered money by a local firm to run an energy saving class. They could accurately define the cost of heating and lighting of the classrooms. The company needed to pay them not only a rental fee, but also for the energy they used. The first step is to understand the when, where, and the how of energy consumption. Let's have a brief pause here while your slide catches up with ours. To get an accurate overview, it's best to do a survey of the site. Survey to detail all the existing hardware and, if applicable, the producers of energy. You also need to look at the availability of internet or mobile access, summarise the hours of usage. This allows us to calculate where any possible savings can be achieved, and using this, estimate the return on investment period. Depending on the complexity, it may be possible to carry out these surveys free of charge. We then need to monitor usage and collect data. To be clear, that's not just about electricity. To a fully joined up strategy, you will need to monitor other utilities and microgeneration, such as solar PV or wind turbines. Once we've collected this data, what do we do with it? We need to do more than just validate bills. We use it as a stepping stone to reduce usage, know exceptional events, and create action plans. All the data that we can collect should be combined onto a single platform, and then we can interrogate this data correctly. For Serve, this platform is EDV, or Energy Data Vision. EDV has a number of standard reports, but you can also create your own bespoke designs and these to auto-run at intervals defined by you. Let's look at a typical week view. You can see what is often referred to as the top hat section. This shows the highest usage through the middle of the day and reduced usage overnight and at weekends. Good information. It does raise some questions, especially about what is using the energy when the building is occupied and what is creating the peak usage throughout the day. A savings plan could be initiated to reduce the baseline amounts and try to create a less dramatic step from unoccupied to occupied. This moves to the next graph, which is a monthly report. This shows how usage varies through a month. This particular graph, when it's on your screen, a cost or office, there we go, where the bin will be in use 5 days a week. As you can see from the first column that there's often lots of usage on a Saturday. You might also hazard a guess that this particular month is May, since I have no usage on the Mondays at the beginning and at the end, so probably May and Spring Bank. It also highlights some interesting trends. For instance, what creates the dips in demand during the middle of certain days, and why are there small peaks during unoccupied times. This graph also introduces us to goal setting. The lines you see are created by using past data to predict current usage. If benchmarks are exceeded, ED will create an exception report. We'll immediately highlight it. For people with a large portfolio, this can be a simple email. This is used to concentrate on the few problem areas without having to trawl through the data from all of your sites. We have worked with a number of universities helping them reduce energy costs. One key sector is always the halls of residence. Often, heaters are on at the same time as air conditioning units, and those are left open. Working with utility managers and student representatives, we usually instigate a period of close monitoring to create the benchmarks. With this in place, whenever a building exceeds the benchmark tolerance, email is sent to the utilities team, who can instantly react. We take this to the next level and install controls which interlink the various elements and automatically react when conflicting demands are made. Certainly, one of the reasons often given by students is that the systems do not take sufficient account of changes in the outside temperature or are slow to react to them. We've already done research into this problem and can create algorithms that can factor in ambient temperatures and the construction of the building. We already mentioned the problems of managing multiple sites, using exception reports to ensure that benchmarks are complied with. E also has the ability to create league tables, which allow you to see the best and worst performing sites. Buildings of different sizes or configurations, you can enter correction factors so that everyone has the chance to compare themselves against others, and you can create healthy competition in energy saving. To ensure in IMServe that everyone does their bit for energy saving regardless of their position. So it's a challenge to our directors and introduce submetering in their offices. Initially, I am honest, they were not keen. Gradually they became more enthusiastic, and now bragging rights at the weekly exec meetings are much sought after. As well as looking at the data annually, monthly and weekly, we can also drill into each day. The you can see shows usage for each hour against the benchmark. To make it easier to read, you can create different profiles with different colours. You may want to do this to register full opening, part opening, times when the cleaners are in, or times when the building is closed. Alternatively, it can indicate different energy tariffs, such as peak and off-peak, that are charged by your suppliers. We get this level of granularity even with non-half-hourly reads, but the speed the data can be accessed will be dependent on how often you load the data. All hourly customers are used to the concept of day+1 readings. This means that every half hour reading is taken, and at the end of each day, 48 measurements are loaded into the database. Non-half-hourly customers with smart meters, this data is registered but may be collected monthly. This means it could be up to a month before you are aware of an exceptional event. Our system typically uploads the data every day, allowing you to review it each morning. However, it's also possible to collect live data. It gives you instantaneous information on exceptions and also allows us to see the effects of changes. This is extremely useful when we want to introduce the concept of energy saving into the classroom, because we can see the results during a specific lesson period. Seeing that the data is collected every half hour and that we can view the results of this effectively live. EDV can also create graphs which show data as energy usage, energy costs, or carbon emissions. To have the presentation of this data more user-friendly, we also create dashboards. These are tailor-made displays which highlight the information as you want to present it. Corporate customers are often displayed in receptions, or industrial customers, they're used to create competitiveness between different production lines. And schools, you may want to have these in the individual classrooms. Schools with live data feeds, they aim to make energy usage a part of your curriculum. We are often told reducing the set temperature of the central heating system, by 1 degree saves 8%. You can now check this information and you can see it in action. Dashboards can have live information on ambient temperatures or wind speeds, which can be useful for microgeneration. Also show real-time energy use and savings, and even compare these across different time frames. We also display the value of savings in different formats. It can be straightforward pounds and pence, could be kilograms of CO2, or it could even be compared to the CO2 generated by an average family car. For schools, we make the data even more accessible so that everyone can understand it and everyone can see that they're making a real difference. Here are a couple of dashboards that were created for a local school. See, we have tried to display information in as friendly a manner as possible. Measures we have explained require behavioural change to drive improvement. There are, however, systems that can control certain amounts of usage. I pass you over to my colleague Jimmy, who will explain some of the hardware that can be used.
Thank you. Just to give you a background about myself, I'm Jimmy Sohal. I have 10 years experience in energy procurement, energy consulting, solutions, and BEMS applications. What I'll be talking to you about is about control, what control means in building, and how it can help you reduce energy consumption and save costs. So let's get right into it. Generally, there's 3 ways of saving energy. The first one is by improving behaviours. This is obviously including staff, asking them to switch things off when they need to be switched off, and that way reducing energy. The other way is by implementing control, and that is something that I'll be talking to you about today. And last but not least is upgrading equipment. Now, there's lots of equipment out there which is maybe decades old, which needs to be replaced as technology has moved on, and obviously more kit is more efficient. Main drivers for implementing control generally are around we comply with legislations, improve energy efficiency and eliminating waste, optimising the performance of equipment and systems in buildings, all helping with alarm and fault handling. There's an emphasis on increased efficiency in maintenance maintenance in terms of cost and maintenance of kit, but also to change out obsolete systems that need upgrading. So what is a building energy management system? It really is a programmable controller which contains building blocks, software, type controllers, and with larger BEMS, special functions. It monitors analog and digital devices, but also provides analog and digital control. It's all wrapped together with a network, which is either run by a PC or remote devices. So why building energy management installed? As with about control, is really the main reason why BEMS is installed. It looks after and looks to provide temperature control, humidity control, pressure control, and lighting control. But as James mentioned, it can also act as a central monitoring device for multiple plants and equipment. But also, it's to save energy, and that's what a lot of our customers really want, a BEMS system. So where we find the building energy management system installed? Generally, you find them in large commercial and industrial buildings, but that's not limited. It's not limited to large buildings or commercial spaces. You can also have them in your homes. So if in your boiler cabinet, you'll see potentially a small controller which switches on and off your boiler. You can find them in plant rooms. You can find them in boiler houses, and also in ventilation plant rooms. But if you look about an air conditioning unit, they're in ceiling spaces, and potentially they are also under control. So when would a building energy management system be installed? Well, it can be installed at any time of the life of the building. Generally, it's during a new construction or during a building refurbishment. Again, the building has been built and after a number of years. What we're finding more and more these days is that customers are retrofitting BMS solutions or applications after the change in building use. So really, at any time you want. So what is a building management system, and what does it actually look like in terms of architecture? The hardware building automation system and control system is hierarchical in structure and divided into at least the following three levels. The first level is the management level, which is generally the brain of the system. Then you have the automation level, which is generally the heart of the system, and then you have the field level, which actually provides all the information back to the various levels. What these actually look like? Well, talk about three main levels. This is all wrapped together once again by a network, which allows devices to communicate across a physical distance. Either this can be a local area network, or across a wide area network, or even remotely. This basically means that information can be accessed from anywhere in the world, ensuring that you have total building continuity. This is a typical example of a BMS layout. These are the main three levels: management level, controller level, and the field level. Well, I'll start with the field level. So what kind of equipment will you find at the field level? Generally, these are sensors, valves, pumps, motors, lights, and so forth, and intelligent versions of what I've just mentioned. Control level, generally in the way that this piece of kit receives signals from a field device, as just mentioned, and according to their programmed operating parameters, takes into account control of the plant. There's three types of digital controllers. There's standalone, which basically means they're not capable of communicating with other devices in the network. There's network controllers, also known as nodes, which communicate with each other on the network and to other devices in the network. Some of the network management capability and function as a gateway or protocol converters. That are more frequently used by IMServe are web-enabled controllers. Controllers which contain a built-in web server which can be directly or wirelessly be connected to an IP network. It's not just the program, but the graphics as well, which can be accessed using any web browser. Here's an example of an air handling unit. So taking into account, at a field level, you've got temperature sensors, humidity sensors, pressure sensors, air quality sensors, and flow sensors within an air handling unit. On the right-hand side, a bit small, but is basically a picture of what the system would be looking like if it was on a larger screen. So I carried out a exercise for a university more recently, which involved in the control and optimization of an air handling unit. In order to achieve correct operation, I have replaced all the sensors and fitted a new controller. And over a 12-month period, this achieved a saving of 20% of operating costs. All control and monitoring of the air handling unit is done remotely by IMServe, Energy and Control Bureau team. Example is using valves. So once again, at the level, you've got valves. This particular building, local authority building, recognised that there were heating areas there was no demand, where there was no demand. And using valve actuators and local control systems were able to zone the building and provide a true demand heating system. By utilising the latest in microwave occupancy sensors, we would ensure the system was only operating when required and heating rooms only when they were in use. By taking this approach, we achieved energy saving 35%, which they were very grateful for. Other elements that can be controlled by a BEMS include fans, inverters, dampers, humidifiers, boilers and chillers. But this is not necessarily the end of the list. Anything can be controlled potentially. Anything that can be switched on or off can be actually controlled by a BEMS system. Furthermore, case studies. Basically, this is a local authority building. When survey came up with a proposal, we found the cost of installing a BMS system in this particular building was £13,000. And what we did was actually control the heating, lighting and cooling in the building. This was done with various sensors around the building, whether they're internal or external, all by our bureau team. The return on investment for this particular project was 16 months. So once again, we came up with a control strategy, but however, the site was managed by the site manager, i.e. he could change the controls as and when they wanted. For example, but taking a school into account, once again, survey came up with a solution which is £7,000 with return on investment of 24 months. In this application, we split the lighting out in corridors and classrooms, put internal temperature and external temperature controls in, and also started to control the air conditioning units. But more, we put some AMR in, so they can actually see the whole of their energy usage and also see energy savings in real time. Once again, we set a control strategy, handed it back over to the site, which then they managed. General savings and control solutions, I've mentioned some of them, but let's talk about them in a little bit more detail. So from a control point of view, we lower the set points for heating. We increase the set points for cooling. This basically puts less strain on the actual boiler or the air conditioning unit. We can also ensure the cooling and the heating systems are not on simultaneously. From lighting controls, let's look about lighting. So if we implement time schedules based on lighting control, i.e. they should come on and go off on a particular time, that will save you money. If you implement switching on and off, so for example, in a school, you could have 40% of the lighting on when the staff is in, and when 10 minutes before the children are going to enter the building, you could switch 100% off. That could also save you money. Introducing lux level sensors, i.e. within buildings where you've got large amounts of glass and lighting nearby, if there's no lighting coming through the actual windows, then that particular bank of lights can switch off. But overall, the best thing to really do is upgrade inefficient lighting with energy efficient lights or LEDs. Other savings is actually optimising the system, allocating sensors if necessary, or replacing obsolete products, or readjusting existing time schedules. You'll be surprised how much you can actually save. We also do day in, day out. I just want to take you through now is typically how we would approach a BEMS application. The thing I would really do is have a conversation with the customer at top level. What do they want to achieve? What kind of reduction strategies do they have in place at the moment? Do they have any behavioural change type of schemes running? And do they want to implement control? How much do they really want to save? Once I've got answers to these questions, I can then take it away and start talking to them about the kind of kit they have on site. What I would personally suggest is a survey, and surveys not just AMT sites but also for BEMS. So what we'll do is provide a non-intrusive survey which will tell us what's on site, controlling what, if there is current control or if there's no control at all. We'll come up with a proposal or a plan which allows the return on investment, which allows the actual application and the solution we're going to come up with, and plan for install. Now, install is quite important because there's many sites which need to either make arrangements for IT to be there, or security, for example. So we'll discuss this in some detail, and our Bureau team will definitely be involved in this. Once we've installed the actual kit, we'll ensure that we commission, and if you want us to operate the BEMS system, we can also do that for you. Because we provide a 24-hour, 7 days a week Bureau service. It also deals with alarms, handling, checking for system errors. Summary. The energy management system is a computer-based system that controls the environment within a building and is designed to maximize energy efficiency. BEMS system will usually control power systems, heating, ventilation and air conditioning systems, security, access systems and so forth. The use of a BEMS system allows for good control and comfort conditions within a building and effective monitoring and targeting of energy consumption. But nothing away from what Jane said. The use of building energy management system has many benefits for the occupants, the building owner and the maintenance company. For the occupants, a BEMS maintenance a good control of internal conditions with the opportunity of individual room control and offers effective monitoring and targeting of a building energy consumption. For the owner, the installation of a BEMS can increase rental value, as well as allowing for flexible building use, and the internal conditions can easily be changed once the occupant has changed also. The system requires little maintenance and offers ease of information availability if there is a problem. With detection of problems, solutions can be found quickly and effectively. So in conclusion, the journey starts at different places for different organisations. We know this because we speak to a lot of our existing customers and new customers on a daily basis. However, in order to really get into the guts of energy efficiency, we must monitor, visualise that information, and if anything, take control of it. I think James really touched on the AMT system, and I've spoken briefly about the BEMS system. And what really, we've got some questions which literally come through. And I think between myself and James, we'll try to answer as many as possible. I've got a question for you, James. First question is, we have some very old water meters on a remote site. Do you still collect the data?
That's a good one. Typical sales answer is yes, but. Basically, if the meter is pulse enabled, then we attach a data logger to it, and then we collect the data remotely, as we would with with the electricity meters. However, if the meter is very old, it may have this ability, in which case, unfortunately, we'd have to replace the meter. Normally, what we do is we'd recommend that we do a survey, but if you have a lot of these things spread around, it may be possible to actually, if you to do without surveying. If you can send us the details and maybe send us a photo of exactly where the meter's located.
I've got one for you, James. Hopefully we answered that question. We have several diesel tanks which currently have manual reads on them, which we currently, manually read. Can you help us with this?
Certainly can. As far as I'm concerned, we can measure any product. So whether it's gas, whether it's electric, whether it's diesel, whether it's water, it doesn't really make any difference. The interesting thing about something like a diesel system, of course, is with the exception reporting, you can also then create a report that tells you when you need to reorder the stuff. Okay, I think I've spoken enough there. A couple for you here, Jimmy.
Okay.
Someone asks, what's the typical return on an investment that you would achieve with a BEMS?
I get this question all the time. It really does depend, and although some of my examples, which I just presented a few minutes ago, range from 12 to 24 months. I mean, typically, I would say, and this is typically, would be 24 to 36 months, without raising too much expectations. But we have also achieved, in some cases, a return on investment of 12 months and less. But this is, in exceptional circumstances where there's no control at all for a particular site. But certain things you need to take into consideration is the size and the use of the building, how you spend and the energy uses, and what you wish to control. So the more things you actually control, potentially, the more you can save. It's not always the case, but that's generally how it works.
Okay, one of our one of our attendees here asks, savings that we've quoted are net on hardware investment. Yes,
that's correct. So it's net on hardware investment. Absolutely right. So once again, if it's £7,000 installation charge, and we're saying it's a return on investment of 24 months, then that is a value.
Excellent. I have another question here. I guess another one you've had before. So I'm really interested in including control in some of my buildings. How is that?
I think I've kind of slightly mentioned that we have a top-level conversation with our customers. So if you want to get in touch with myself or James, there'll be a slide at the end of this webinar which will give you all of our details. Drop an email. We're happy to have a phone conversation, follow a face-to-face meeting, and let's take the journey somewhere. Basically, let's get involved.
Okay. I've got another one here. Maybe I can answer this one. It says we've installed PIR sensors to help save energy, but they had to remove them because the lights kept turning off when the students were in the classrooms. You'd be surprised how often we come across this. It only happens in classrooms where the kids are quiet, but there you go. PIR sensors are extremely useful, and we do install them, but we generally recommend that you put them in the corridors or maybe in the toilets, not into the classrooms. In the classrooms, we recommend lux sensors, which are the ambient light, and then use this for the control. To optimize this and get the maximum benefit from them, what we often suggest is that you look at the way your lights are configured and set these so that they are parallel to the windows rather than perpendicular. So that effectively then, as you get more light coming in through the windows, the blocks of lighting can go off towards the back of the room. This could be either of us. I'll give it you, Jimmy.
I do have another one just come through. It says you mentioned the initial action is a survey. How is it possible to determine the cost of such a survey? Well, we do have fixed costs for surveys, and potentially, I'd rather not discuss this in this webinar. It's a frank conversation between us and ourselves. So there's different types of buildings, there's different types of controls, there's different sizes, there's different requirements, and we do have a set price for each one. I can definitely answer that question, but just not now.
Okay. As I was saying, I have another question here, which I think probably is a mixture between the two of us, but I'll let you answer. It says, can dashboards with a BEMS system?
Yes, most sophisticated BEMS do have dashboard displays, and they act as real-time dashboards, and in some cases the dashboards are also used for control panel where alerts and reports are being produced in real time. So the answer is yes.
Excellent.
Quickly, just one more slide. Next, so if you would like some further information, as we mentioned, drop us an email, either at marketing@imserve.com or myself, james.sol@imserve.com, or james.palmer@imserve.com. Thank you for participating. We hope you enjoyed it. Hope you've learned something. I know we have. And we'll speak soon. Thank you very much.